Okay, here's the other part of the homework from this week, which was a couple of other questions from the 1997 HSC paper. First one's a circle geometry question, which we've learned about in Extension 1. And it's saying that these points R and S lie on a circle, centre is O, radius of the circle is 1. The tangents to the circle at R and S, meet at T. So that's useful, because that tells us we've got a few right angles in here. The lines OT and RS meet at U. So OT and RS will meet at U. So there'll be another right angle in there. And a perpendicular. It's a right angle. Show OU times OT equals 1. Now, once we start talking about multiplying things together, we should be thinking similar triangles. So we should be thinking about a triangle with OU and a triangle with OT. And trying to show they're similar. So in triangle, so if we go OUS and triangle, so OUS, U being the right angle, I'll call the other one OST. Then straight away, angle SOU and angle SOT, it's common, well, it's a common angle, so they're equal to each other. Angle OUS is equal to angle OUS is equal to angle OST, and that's equal to 90 degrees, and that's because the angle between a tangent and radius is 19 degrees, 90 degrees even. So therefore, triangle OUS must be similar to triangle OST, because if the two angles are equal, then the third angle must also be equal. So if the triangles are similar and the sides are in the same ratio, so I can simply say that OU over OS must be equal to OS over OT. OU over OS is OS over OT, just matching up the corresponding sides of the triangles. And that means OU over 1 is equal to 1 over OT, because OS was given to us as 1. So it simply comes out as OU times OT is equal to 1. So that was a nice, straightforward circle geo question. Not too hard at all there, that particular one. The other question I left was question 4, which was to look at an expression for cot 2a and to work through a trig identities question. So again, something from the Extension 1 course that often comes up. So, cotan 2a, you want to use the tan 2a expression, and we know that tan 2a is equal to 2 tan a over 1 minus tan squared a. So cotan 2a is simply 1 over tan 2a, which is 1 minus tan squared a over 2 tan a. So that was again nice and easy. And you've got to look for these little gems in the HSC. They're going to be hidden their way, and they're going to be nice and straightforward. Okay, so that tan a and negative cotan a satisfy this equation. So let's just throw them in there for the second part to start with. So we're going to get tan squared a plus 2 tan a cotan a minus 1. We're going to try and show that is equal to 0 when we sub in tan a. And so cotan 2a, that's cotan 2a there. So we've got tan squared a plus 2 tan a times 1 minus tan squared a over 2 tan a minus 1, and you can see this is going to simplify down to give me tan squared a plus 1 minus tan squared a minus 1, which is equal to 0. So therefore tan a satisfies, and we'll do the same then with cotan of a, negative cotan of a, so you're going to get cotan squared of a plus 2 times negative cotan of A times cotan 2A minus 1. And again we're going to go through and we're going to get cotan squared of A plus, I'll make that minus 2 cotan A, and again I'll use this 1 minus tan squared A over 2 tan A minus 1, and I'm going to keep working here. This is 1 over 2 tan A, and 1 over 2 tan A is cotan A. So I'm actually going to end up, 2 can cancel, cotan A times cotan A. So I'm going to end up with cotan squared A minus cotan squared A of 1 minus tan squared A minus 1, and then I'll keep expanding and I'll get cotan squared A minus cotan squared A, and cotan times tan is going to be 1 minus 1, which we can see is equal to 0, so therefore negative cotan A satisfies. So a little bit of manipulation through the trig functions. Okay, next question. Hence or otherwise, find the exact value of tan pi of 8. And so, since they're the roots of the quadratic equation, then we know that, and there's only 2 roots in here, so we know the sum of the roots. So we can say that so tan of A plus negative cotan of A must equal to, sum of the roots one at a time, negative B on A. And from our equation up here, that's negative 2 cotan 2A. And so if I then let A equal pi on 8, I get tan of pi on 8 minus cotan of pi on 8 is equal to negative 2 cotan of pi on 4. Now, cotan pi on 4 is going to be equal to 1 because it's just 1 over tan pi on 4. So I've got I've got tan of pi on 8 minus 1 over tan pi on 8 is equal to negative 2. And so if I come through here, I've got tan squared pi on 8 minus 1 is equal to negative 2 tan pi on 8. And all I want to do is solve this equation to get my solution for tan pi on 8. So tan squared pi on 8 plus 2 tan pi on 8 minus 1 is equal to 0. It's a quadratic function, can't be factorised, and so I'm simply going to go tan pi on 8 is equal to, and use the quadratic formula, negative b plus or minus square root of b squared, which is 4 minus 4ac, it's going to give me plus 4 all over 2a. So I've got 2 is common to all of that, and so I'm going to get that as negative 1 plus or minus root 2. Now, tan pi on 8, first quadrant, tan pi on 8 is greater than 0, so therefore tan pi on 8 is equal to negative 1 plus root 2. That was kind of neat, using the sum of the roots and then subbing in and solving the quadratic equation to get it. Okay. Hence find the exact value of tan pi on 16 minus cotan pi on 16. So that's simply going to be using what we did up here earlier. Tan of A minus cotan of A is negative 2 cotan of A. So putting pi on 16 in there, I get tan of pi on 16 minus cotan pi on 16 is equal to negative 2 cotan of pi on 8. So that means I've got tan of pi on 16 minus cotan of pi on 16 is equal to negative 2. Now, cotan is just 1 over tan, so that's 1 over this, over negative 1 plus root 2. And so it would be worth here, at this point, rationalising that denominator. To do that, I've got to multiply pi by its conjugate. And actually, probably a better way to think about that is negative 2 over root 2 minus 1, and then times by root 2 plus 1 over root 2 plus 1. And when you work that out, you'll get negative 2 outside of root 2 plus 1 as the exact value for this.